You know that feeling, right? You walk up to a door, maybe it's glass, maybe it's got a weird handle, and you just stand there. Push, pull, slide.
Uh-huh. And you instantly feel a bit dumb, like, why can't I figure out this door?
Exactly. Or those stove tops with the controls in a straight line, but the burners are in a square. Which one controls which? It's maddening.
It really is. And that feeling, that, self-blame, that's actually a huge signal. Most of the time, it's not you, it's the design.
Precisely. And that is exactly what we're digging into today. This deep dive is all about the principles from Donald Norman's brilliant book, The Design of Everyday Things.
Yeah, we've pulled together key ideas from the book, some updates he's made, examples, basically the core stuff.
Think of this as, like, your guide to understanding why some things just work and others make you want to tear your hair out.
Right. The goal isn't really to make you a designer overnight or anything.
No, no.
It's more about equipping you with a lens, a way to look at the world and go, that's why this remote control is so awful, or, that's why this app feels so intuitive.
Yeah, those aha moments. Because good design, it just fades into the background, doesn't it? You don't even notice it.
Totally invisible. It just lets you get on with what you want to do.
But bad design, oh boy, it screams at you.
It really does. It gets in the way.
Okay, so where do we start? What are the absolute fundamentals Norman talks about for good design?
Well, he boils it down to two main things, really crucial ones: discoverability and understanding.
Discoverability and understanding.
Okay, so discoverability is, can you even figure out what actions are possible? Like, where do you touch it? What parts move? What can you do with this thing?
Right. Is it obvious what's interactive?
Exactly. And then understanding is, okay, I see I can push this button, but what does it mean? What will happen? How is this thing actually supposed to be used?
So first, can I find the controls? And second, do I know what they do?
You got it. If you don't have both, you're kind of lost. You're just guessing.
Okay, so how do designers make things discoverable? You mentioned those doors. This must be where affordances and signifiers come in.
Spot on. Affordances are basically the properties of an object that suggest how it could be used. What actions does it afford?
So like a chair affords sitting, a knob affords turning.
Exactly. A flat surface affords putting things on it. The physical characteristics suggest the actions. And ideally, these affordances are perceived, they're obvious just from looking.
Like seeing the handle on a mug, you just know you're meant to grip it there.
Perfect example. But just because something can be done, the affordance exists, doesn't mean it's clear how or where to do it.
Oh, okay.
That's where signifiers are key.
Yeah.
Signifiers are the signals, the cues, could be visual, could be sound, whatever, that tell you where the action should take place. They communicate the affordance.
So the handle signifies where to grab. The push plate on the door signifies where to push.
Precisely. The affordance is being openable. The signifier is the plate or handle showing you how.
And that London hotel sink Norman talks about. That's a failure signify, right?
Oh, completely. The sink obviously afforded draining. There was a plug. But there is absolutely no signifier, no lever, no button, no visible mechanism to tell you how to make it drain.
You had to push down on the plug itself, which isn't standard.
Right. Zero indication. It perfectly shows why you need both. You need the affordance, know what's possible, and the signifier, know where and how to act. They've got to work hand in hand.
Okay, makes sense. So discoverability helps us find the controls and figure out what they might do. But how do we build that deeper understanding of how the whole thing operates? That sounds more like conceptual models.
Yeah, exactly. A conceptual model is basically the explanation we carry around in our heads about how something works. It doesn't have to be technically accurate, down to the last circuit.
Just needs to be useful.
Exactly.
Yeah.
Useful for predicting what happens when you do something. And we, as users, we build these mental models based on our interaction with the thing and critically based on what Norman calls the system image.
The system image.
Yeah.
That's like everything the device presents to us. Its shape, the labels, instructions.
Everything. The physical structure, the way it behaves, the sounds it makes, any documentation. That's the only way the designer can really communicate their intended model to the user.
So you've got the designer's model, how they think it works. The user's model, how I think it works. And the system image, what the thing actually shows me.
Precisely. And the designer's job is to make that system image accurately reflect their model so that the user can build a correct or at least functional user model.
And when that system image is misleading, like those old General Electric fridge controls he mentioned.
That's a classic. The layout of the temperature controls didn't actually map logically to the fridge and freezer compartments. So the system image, the knobs and labels, gave you a completely wrong idea.
You'd adjust one, thinking you're cooling the fridge.
And you'd accidentally be freezing the lettuce because it was controlling the freezer section.
Yes.
Your user model was totally out of sync with reality because the system image lied, essentially.
Okay, this is clicking. Now, besides showing us what to do, good design often helps us figure out what not to do, or makes it hard to mess up. That must be constraints.
Absolutely. Constraints are super powerful. They limit the possible actions, guiding you towards the right ones by making the wrong ones difficult or even impossible. Norman outlines 4 main types.
Okay, let's hear them.
First, physical constraints. These are purely based on physical properties. Like trying to put a large peg in a small hole, it just won't work.
Or a USB plug upside down.
Exactly. The Lego motorcycle example he uses is great. The windshield piece physically only fits one way. No thought required. Physics does the work.
Got it. Physical limits. What's next?
Second, cultural constraints. These are learned conventions, shared understandings within a culture. Traffic lights are the obvious one. Red means stop, green means go. Pretty much everywhere.
Or reading direction, maybe.
Yeah, or even social norms like which side of the sidewalk to walk on. These are learned, not physically inherent, and they can cause trouble with new tech where conventions aren't set yet or across different cultures.
Makes sense. That's 2.
Third is semantic constraints. These rely on the meaning of the situation, the context. Back to the Lego motorcycle. You know the seat goes roughly in the middle, facing forward, because that's what makes sense for a motorcycle. The meaning guides assembly.
You wouldn't stick the handlebars on the wheel because it violates the meaning of handlebar.
Precisely. And finally, number 4 is logical constraints. This is about reasoning. If you're assembling something and there's only one piece left and only one place it could possibly fit, logic tells you that's where it goes. You deduce the correct action.
Physical, cultural, semantic, logical. Okay? So designers can use these to subtly guide us. Now, after we take an action, how do we know it worked? This is feedback, yeah.
Crucial. Feedback is the return signal. It tells you the system received your input, what it did, and what the result was. It needs to be immediate and informative.
Like when you press a key on your keyboard and the letter appears instantly on screen.
Perfect. Or a clear click sound when a switch engages.
But bad feedback is everywhere. Like pressing a button for a pedestrian crossing and it gives this tiny ambiguous flash. Did it register? Is it working? Who knows?
Exactly. Or elevator buttons where the light goes on briefly, then off again. It creates uncertainty, which is frustrating and sometimes even dangerous.
And Norman warns about too much feedback too, right?
Yep.
Especially in complex systems.
Definitely. In an airplane cockpit or an operating room, you can't have alarms going off for every little thing. Feedback needs to be prioritized, clear, and unambiguous. Too much noise, literal or figurative, can be worse than too little. It needs planning.
Okay, got it. Feedback closes the loop. What about the connection between the controls and what they actually control? That relationship is mapping, isn't it?
Yes, mapping. It's about the relationship between the things you manipulate and the results they produce. Natural mapping is the goal, where that relationship feels intuitive, often because it uses physical analogies or spatial correspondence.
The stove controls again. Arranging the knobs in the same pattern as the burners.
The classic example. It leverages a natural spatial relationship. You glance at it, and you instantly know which knob controls which burner. No memorization needed.
Versus the nightmare scenario.
Yeah.
4 burners in a square, 4 knobs in a row. You just have to learn it or keep checking.
Right, and you will mess it up. Norman finds it almost funny how often this basic principle is violated because, as he says, it's not hard to get right.
And what feels natural can vary, right? You mentioned culture earlier.
Absolutely. Our cultural background shapes expectations, like how we visualize time moving left to right in cultures that read that way, maybe right to left elsewhere. That affects how progress bars or timelines feel intuitive.
So there isn't always one single natural mapping for everyone.
Not always, though sometimes conventions do emerge. Like, eventually we all sort of agreed on the moving window idea for scroll bars and mouse cursors, even though it wasn't initially obvious to everyone. Experience builds shared understanding.
Okay, we've covered some really core concepts here. Discoverability, understanding, affordances, signifiers, models, constraints, feedback, mapping. Wow.
They're the building blocks.
So now let's zoom in a bit on the human side of things. The psychology of everyday actions. How do we actually go about doing things?
Well, Norman lays out the 7 stages of action. It's a model of the cognitive steps we go through, consciously or not, when we try to accomplish something.
7 stages. Okay.
It starts with a goal,
Yeah.
what we want to achieve. Then we plan the action. We specify the sequence of steps. We perform the actions. Then we perceive what happened in the world. We interpret that perception. And finally, we compare the outcome with our original goal.
Goal, plan, specify, perform, perceive, interpret, compare. Sounds complex, but I guess it happens fast.
Often subconsciously, yeah.
Yeah.
But designers can think about these stages to see where users might struggle. There are two main potential pitfalls, or gulfs, as Norman calls them.
Gulfs.
The gulf of execution, basically. How hard is it to figure out how to do the thing? How do I translate my goal into actions the system understands? And the gulf of evaluation, how hard is it to figure out what happened? Did it work? What's the state of the system now?
So the gulfs represent the gap between our thoughts and the physical device.
Exactly. And good design bridges those gulfs. Things like signifiers, constraints, good mapping, and conceptual models help bridge the gulf of execution.
Making it easier to act.
Right. And clear feedback and understandable conceptual models help bridge the gulf of evaluation.
Making it easier to understand the results. Got it. He also discusses 3 levels of processing, which sounds interesting. Visceral, behavioral, reflective.
Yeah, these are different ways our brain processes information and experiences. Visceral is the lowest level. It's automatic, preconscious, gut-level reaction.
Like fear of heights or
Mhm.
finding something immediately beautiful or ugly.
Exactly, that immediate aesthetic appeal or repulsion. Designers tap into this for that instant emotional connection.
Okay. Then behavioral.
Behavioral is about learned skills, routine actions, things we do mostly subconsciously, triggered by the situation. Think about riding a bike or typing or using software you know well. It's skilled, practiced action.
Like being on autopilot.
Kind of, yeah. And the reflective level is the highest level conscious thought, contemplation, reasoning, remembering past experiences, assigning blame or credit. This is where you think about your experience, evaluate it, tell stories about it.
So a really enjoyable product probably engages all 3 levels well.
Ideally, yes. It looks good, visceral.
Yeah.
It's easy and efficient to use, behavioral. And it leaves you with positive feelings and memories, reflective.
It's interesting how much emphasis Norman puts on us being storytellers, always trying to make sense of things by creating conceptual models, even if they're totally wrong.
We just have this deep need to understand why. We see something happen we want to cause. So we build these little mental stories, these models to explain the world.
Like the thermostat example, people thinking turning it way up heats the room faster.
Exactly. It's a simple but incorrect model based on perhaps how a gas pedal works. We create these models constantly.
And this can lead us to blame ourselves when a design is bad, right? That like learned helplessness thing again.
It's a huge point for Norman. We encounter a confusing door, a baffling website, a VCR that flashes 12.00 forever, and we think, I'm just bad at technology or I'm stupid.
When really, the design failed us.
Precisely. We internalize the failure. Learn helplessness sets in, and we might avoid similar devices in the future. Norman argues strongly that designers need to take responsibility. Human error is often a symptom of design error.
Yeah, he advocates for designing for humans with all our quirks, like systems that accept different date formats instead of forcing one rigid structure.
Right. Embrace flexibility, anticipate variations, which connects to another key idea, knowledge in the head versus knowledge in the world.
Okay, what's the difference there?
Knowledge in the head is everything you've memorized, facts, procedures, how-tos. Knowledge in the world is the information available externally, in the environment, signs, labels, physical constraints, the way things are arranged.
So remembering your PI is knowledge in the head. Reading the instructions on the ATM is using knowledge in the world.
Exactly. And Norman's point is that we often function perfectly well with very imprecise knowledge in our heads because we rely heavily on knowledge in the world to guide our actions.
Like knowing roughly what coins look like versus being able to draw one accurately from memory.
Perfect example. Recognition, using knowledge in the world, is easy. Recall, using knowledge in the head, is much harder. We offload a lot of the cognitive burden onto the environment.
So there's a trade-off for designers. Rely on memory or provide external cues.
Absolutely. Knowledge in the head is faster once learned, but requires learning and can be forgotten. Knowledge in the world requires less learning, but might involve searching or paying attention. Good design often uses both.
Like pilots using checklists. They have stuff memorized, but the checklist ensures nothing is missed.
Exactly. They combine internal knowledge with crucial external knowledge. It makes the whole system more robust.
Okay, let's circle back to those pillars. Constraints, discoverability, feedback, they keep coming up.
because they're just that fundamental. They make interaction possible and understandable. Think about those destination control elevators again, where you punch in your floor before getting in.
Right, it breaks the established convention. The discoverability is low initially.
Totally. You're standing there looking for the buttons inside, but they aren't there. It shows how changing ingrained patterns, even for efficiency, can cause confusion if the design doesn't clearly guide the user through the new process.
And it's wild how often simple things like light switches or faucets are badly designed.
Isn't it? A row of identical switches controlling lights in different parts of a room, terrible mapping. Or faucets where up means hot on one and down means hot on another. No consistency, no clear feedback.
Which brings us to things like forcing functions. These are constraints that make you do things in the right order.
Basically, yes, they constrain actions to prevent errors. You can't start your car without the key in the ignition. That's a forcing function. Or needing to close the microwave door before it will start. They often relate to safety or security.
And things like interlocks and lockouts are types of these.
Yes, specific kinds of forcing functions. An interlock forces actions in sequence. A lock-in keeps an operation active, preventing you from stopping it prematurely, like maybe saving a file. A lockout prevents an event from happening, like locking a door.
We also mentioned sound as feedback. It can be good or bad.
Very much so. A subtle click can confirm an action. A loud, annoying beep every time you press a button. Not so good. Designing sounds, like for electric cars needing to alert pedestrians, is tricky. You need awareness without annoyance.
Norman also talks about skeuomorphism, right? Making digital things look like their old physical counterparts.
Yeah, like early digital calendars having leather textures and page-turning animations. It can help people transition to new tech by making it look familiar. But it's often not the most efficient design long-term, just a temporary bridge.
Okay, we keep bumping into this idea of human error. Norman really wants to reframe that, doesn't he, as bad design.
He argues very strongly that labeling something human error is often a cop-out. It blames the user instead of examining the system that allowed or even encouraged the error. Designers, he says, have an obligation to make things understandable.
He differentiates between slips and mistakes, which seems important.
Very important. A slip is when you intend to do the right action, but you mess up the execution. You know what to do, but you accidentally do something else, like hitting the wrong key or turning left when you meant to turn right.
Okay, unconscious error in execution.
Right. A mistake, on the other hand, is when your intention or plan itself is wrong. You might execute the plan perfectly, but the plan was flawed from the start because you misunderstood the situation or had the wrong goal.
So slips are errors of doing, mistakes are errors of thinking.
You could put it that way, yeah. And there are different types of slips he identifies.
Well,
Well, action-based slips are doing the wrong action, like a capture slip, where a frequent action takes over a less frequent one you intended. Or a description similarity slip, where you act on something that looks like your target. And mode error is doing the right action, but the system is in the wrong mode, so the action has an unintended effect. Think airplane autopilots.
Oof, yeah. Mode error sounds scary.
It can be. And then there are memory lapse slips, which is just forgetting. Forgetting to turn off the stove, forgetting a step in a sequence.
This ties into the Swiss cheese model, doesn't it? The idea that accidents usually have multiple causes.
Exactly. The model suggests accidents happen when failures occur at multiple levels, like holes lining up in slices of Swiss cheese. Each layer of defense, design features, procedures, training, might have small weaknesses, but disaster only strikes when all the holes align. It shifts focus from blaming one person to fixing the systemic issues.
So don't just blame the last person who touched it. Look at the whole system.
Right. And Norman gives concrete design advice to minimize errors. Understand why they happen, build in checks, does this input make sense? Provide an easy undo, make errors obvious and easy to fix. Treat errors not as failures, but as approximations of what the user wanted.
That's a much more forgiving approach. He also mentions interruptions being a big cause of error.
Huge. Interruptions derail our thought process and make slips, especially memory lapse ones, much more likely. Designing systems that handle interruptions gracefully is important. And things like confirmation dialogues, they need to be timed well, not interrupting constantly for trivial things. An undo function is often much better than asking, "Are you sure?" all the time.
So the takeaway is design for error. Expect it. Plan for it.
Absolutely. Don't assume perfect users.
This philosophy seems baked into design thinking. It's about the process of designing with humans in mind.
Very much so. Norman champions human-centered design, HCD. It's iterative. It starts with understanding the users, observing them, talking to them. Then you generate ideas. You build quick prototypes. You test them with users. You learn and you repeat. Observe, ideate, prototype, test. Over and over.
Keeping the human at the core throughout.
Always. He also mentions activity-centered design, which is slightly different. It focuses less on individual user psychology and more on the activities people are trying to accomplish. Design the tools to support the activity really well and trust that people will figure out how to use them for that purpose.
But designers don't operate in a vacuum, right? The business world imposes its own constraints.
Oh, absolutely. Time pressures, budgets, marketing demands, needing to compete. These are all real-world constraints. Designers constantly have to balance usability goals with business realities.
And that can lead to things like featureitis,
Yeah.
just piling on more and more features.
Yeah, driven by customer requests or trying to one-up competitors. Often adding features makes the product more complex and less usable overall, but it looks good on a spec sheet.
It's a tough balance. And new technologies constantly force changes. But people adopt new things slowly sometimes.
Definitely. Norman contrasts incremental innovation making existing things slightly better with radical innovation introducing something entirely new. Radical ideas, like the transistor or maybe even GPS, often take decades to be fully integrated and understood.
The video phone example again. Technically possible for ages, but only took off recently.
Right, technology changes fast, but people and culture change slowly. That's a constant tension.
He touches on whether tech makes us smarter or dumber.
Yeah, and concludes it's more about the combination. Humans plus well-designed technology can achieve more than either alone, like freestyle chess, where human-computer teams outperform humans or computers alone.
And he even talks about the future of things like books and the need for expertise even when creation tools get easier. And the moral side of design sustainability, not making junk.
It's a holistic view. Product development is complex technical, business, social skills all needed. But he stresses that while the technology changes, those core principles of interaction, the things we've been talking about, they're pretty permanent because human psychology doesn't change that fast.
So wrapping up this deep dive, the core message seems to be, good design is discoverable and understandable. It uses affordances, signifiers, conceptual models, constraints, feedback, and mapping effectively.
And when you struggle, it's probably not you, it's the design. We should look for system flaws before blaming human error. Design needs to be human-centered, iterative.
Hopefully after this, you, our listener, will start seeing the world a bit differently. You'll notice those frustrating door handles or confusing websites, or maybe appreciate the elegance of something that just works seamlessly.
Yes, start applying these ideas. Notice the design choices around you. Why does this work well? Why is that so annoying?
And here's a final thought to leave you with. As technology gets more integrated, more invisible smart homes, wearables, embedded interfaces, how do these design principles need to evolve? What new challenges and responsibilities will designers face in making sure these increasingly powerful technologies actually serve us well without becoming confusing or intrusive? What are the next generation of everyday things we need to design thoughtfully?
That's a big question. How do we design for a world where the computer isn't just on your desk, but all around you, maybe even in you? The principles might stay the same, but applying them will definitely get more interesting.